This video is about sequence, factorial, and recursive sequence. What is sequence? A sequence is a list of numbers, usually based on some defining rule. A sequence may also be represented in the abbreviated form like curly bracket, a sub n, curly bracket. So this is the nth term. So this in expanded form, a sub 1, a sub 2, a sub 3, a sub n. So a sub 1 stands for first term, a sub 2 stands for second term, so on. A sub n stands for nth term. And the domain is a set of positive integers, 1, 2, 3, 4, so on, n, and keep going. Occasionally, it is also convenient to begin a sequence with a sub 0, so that the terms of the sequence becomes a sub 0, a sub 1, a sub 2, a sub 3, a sub n, so on. And the domain is the set of non-negative integers. So it will start like 0, 1, 2, 3, n, and so on. There are two types of sequences, infinite sequence and finite sequence. Infinite sequence is a function whose domain is the set of positive integers 1, 2, 3, 4, and 7. An example is like a 2, 4, 8, 16, and just keep going forever. In finite sequence, a sequence whose domain is the set of first and positive integers. Example of finite sequence like a 2, 4, 8, 16, 10, 24. Alternating sequence. Alternating sequence is a sequence in which consecutive terms alternate in sign. So like this one, 2 comma negative 3/4 and 4/9 and the comma negative 5/16, and then you have 6/25 and just keep going. So you can see the first term is positive, and then next term is negative, and then you have a positive and then negative and then positive. Though here all the terms alternate in sign. So this sequence is an example of alternating sequence. So here is an example one. So we're going to write the first 5 terms of this sequence, and the nth term is a sub n equals to negative 1 to the n plus 1, 3 over n. So now we can substitute n equals to 1 in this nth term. So you get becomes a1 equals to negative 1 to the 1 plus 1 times 3 over 1. Now 1 plus 1 becomes 2, and negative 1 square is positive 1, and 3 over 1 is 3, so the first term is 3. Now to find the second term, we substitute n equals to 2 in the given this nth term formula. So it becomes negative 1 to the 2 plus 1 and 3 over 2. Now again 2 plus 1 is 3, so negative 1 to the power 3 is negative 1, and times 3 over 2, so the second term is negative 3 over 2. Okay, so to find the third term, so we substitute n equal to 3 in the given nth term formula, so it becomes negative 1 to the 3 plus 1 and 3 over 3. Now 3 over 3 is 1, 3 plus 1 is 4, so negative 1 to the 4 is positive 1. So 1 times 1 is 1. So the third term is 1. To find the fourth term, we substitute n equals to 4 in the nth term formula. So this becomes a4 or a sub 4 equals to negative 1 to the 4 plus 1, 3 over 4. Now 4 plus 1 is 5, so the negative 1 to the fifth power is negative 1. So negative 1 times 3/4 is negative 3/4. So fourth term is negative 3/4. To find the fifth term, we put n equals to 5 in the given nth term formula. So it becomes a sub 5, negative 1 to the 5 plus 1 and 3, and changes to 5, 3 over 5. So the negative 1 to the 5 plus 1 is 6. So it will be just positive 1 times 3/5, it will be 3/5. So the first 5 terms of the sequence are 3, comma 3 half, comma 1, comma 3 fourth, comma 3 fifth, and so on. So it looks like it's an alternating sequence. Here is an example 2. So nth term is 2n minus 3. So we're going to write the first 5 terms. So we substitute n equal to 1 in the nth term formula. So this becomes a1 equals to 2 times n is 1 n minus 3. Now 2 times 1 is 2 minus 3, so it'll be negative 1. So the first term is negative 1. To find the second term, we put n equals to 2 in the formula. So this becomes 2 times 2 minus 3. 2 times 2 is 4. 4 minus 3 is 1. So second term is positive 1. Now we put n equals to 3 in the formula. So we get an becomes a3. Becomes 2 times 3 minus 3. 2 times 3 is 6. 6 minus 3 is 3. So the third term is 3. To find the fourth term, we put n equals to 4 in the nth term formula is 7 equal to 2n minus 3. So we become 2 times 4 minus 3. 2 times 4 is 8. 8 minus 3 is 5. So to find the fifth term, we put n equals to 5. So it becomes a5 is equal to 2 times 5 minus 3. 2 times 5 is 10. 10 minus 3 is 7. So the first 5 terms of sequence are negative 1, 1, 3, 5, 7. Okay, and this is not alternating sequence. Example 3. So here the nth term is negative 1 to the n plus 1 plus 2. So let's see. To find the first term, we're going to substitute n equals to 1 in the formula. So this becomes a sub 1, negative 1 to the 1 plus 1 plus 2. Now negative 1 square, you become negative 1 square plus 2. Negative 1 square is 1, so 1 plus 2 is 3. So the first term is 3. And to find the second term, we put n equals to 2 in the formula. So it becomes a sub 2 equal to negative 1 to the 2 plus 1 plus 2. Well, it becomes negative 1 to the 3, negative 1 to the third power is negative 1. So negative 1 plus 2 is 1. Now to find the third term, we put n equals to 3 in the formula. So it becomes a sub 3 equals to negative 1 to the 3 plus 1 plus 2, which becomes negative 1 to the power 4. And this becomes positive 1. So 1 plus 2 is 3. So third term is 3. To find the fourth term, we substitute n equals to 4 and the formula, so it becomes negative 1 to the 4 plus 1 plus 2, which becomes negative 1 to the fifth power, which is negative 1. So negative 1 plus 2 is positive 1. To find the fifth term, we put n equals to 5. So it becomes a sub 5 equal to negative 1 to the 5 plus 1 plus 2. This which becomes negative 1 to the 6 plus 2. Negative 1 to 6 is 1, the 1 plus 2 is 3. So first 5 terms are 3, 1, 3, 1, 3. So here is an example 4, and the nth term is negative 3 to the power n. So to find the first term, we put n equals to 1 in the formula. So it becomes a1 equals to negative 3 to the power 1, and negative 3 to the 1 is negative 3. To find the second term, we substitute n equals to 2 in the formula, and this becomes a sub 2 equals to negative 3 to the power 2, which becomes 9. To find the third term, we put n equal to 3 in the formula, and we can a sub 3 equals to negative 3 to the power 3, which is negative 27. So to find the fourth term, we substitute n equals to 4, so it becomes negative 3 to the power 4, and negative 3 to the power 4 is 81. And then substitute n equals to 5 to find the fifth term, so it becomes a sub 5 equals to negative 3 to the power fifth power, which is negative 243. So the first 5 terms are negative 3, positive 9, negative 27, 81, and negative 243. So again, this sequence is what? Alternating sequence. Example 5. A sub n is n over n plus 3. So to find the first term, we substitute n equals to 1. So it becomes a1 equals to 1 over 1 plus 3. 1 plus 3 is what? 4, so it becomes 1/4. Find the second term, we put n equals to what? 2. So it becomes 2 over 2 plus 3, which is 2 over 5. To find the third term, we substitute n equal to 3. So the formula becomes a sub 3 equal to 3 over 3 plus 3. 3 plus 3 is 6. 3 6. 3 6 becomes 1/2. To find the fourth term, we substitute n equals to 4 in the formula, and it becomes a sub 4 equals 4 over 4 plus 3, which is 4/7. To find this fifth term, we put n equals 5. So it becomes a to the 5 equal to 5 over 5 plus 3, which is 5/8. The first five terms are 1/4, 2/5, 1/2, 4/7, and 5/8. So here is an example 6. So the formula is a sub n equal to -1 to the n to n minus 3. And we have to find the missing term. So here's the missing term, the a20. So we write the formula and we just put, this suggests that put n equals to 20. So in the formula, so it becomes a20 equals to -1 to the power 20 times 2 times 20 minus 3. 20 is even power, so -1 to the 20 is positive 1. 2 times 20 is 40, 40 minus 3, and 40 minus 3 is 37. So 1 times 37, so the missing term, a20 is 37. Find the missing term. So here we have n term formula, an is 5n over 3n squared minus 2. We have to find a sub 10. So we're going to substitute n equals to 10 in the given formula. So this becomes a sub 10 equals to 5 times 10 over 3 times 10 squared minus 4. 5 times 10 is 50, 10 squared is 100, 100 times 3, 3 times 100 minus 2, so it'll be 50 over 300 minus 2, which will be 50 over 298. Now we simplify. We can divide both numbers by 2. So we have 25 over 1 over 49. So that's the answer. A tenth term. Example 8. Finding the nth term of this sequence. So now we have a given, before we were given the nth term and we were finding the first 5 terms. Now we're given the first 4 terms and we have to find the nth term. Okay, so let's write down n. The n is 1, means first term, and term is 1. And n is 2, means this indicates second term is 5th. This means third term is 9, and the fourth term is 13th. So we're going to find out when n is n, means what is the nth term. Okay, so we have to see the patterns. It looks like the each term is 3 less than the 4 times the n. So like this one, a1 is 4 times 1 minus 3 is 1. a2 is 4 times 2 minus 3 is 5. a3 is 4 times 3 minus 3 is like 4 times 12. 12 minus 3 is 9. So you see, so from this suggests when n is n, then the an is 4 times the n minus 3. That is another example. So we are given this first 4 terms of the sequence, 3, 10, 29, 66. And we have to find the nth term. So again, we can say this n tells you 1 means first term, 3. n is 2 means second term is 10. 3n means third term is 29. n is 4 means 66. And when it's n, then is an, and we want to find what is an. So we have to look into a pattern relationship, this number with this number. The first term, so first looks like, it seems like if I cube 1 and then add 2, it becomes 3. And then I cube this 2 cube plus 2, it becomes 10. And then if I use 3 cube plus 2, it becomes 29, and 4 cubed plus 2 becomes 66. So the above pattern suggests that we need to add 2 to the cube of the term, number of the term, like n cube. So the answer is A sub n is n cube plus 2. So n stands for the number of the term. So example 10, write an expression for the nth term of the sequence. Assume that n begins with 1. So here we have a sequence negative 2/3, 3/4, negative 4/5, 5/6, and negative 6/7, and so on. So let's start with n stand for the number of the term. So number of term is 1, the term is negative 2/3. Number of term is 2, the term is 3/4. The number of term is 3, the term is negative 4/5. So the number of term is 4, the term is 5/6. The number of term is 5, the term is negative 6. When the number of term is n, what is the term? That's what we have to find. So let's check the pattern. So numerator. So look at the numerator. It looks like 2. If I add 1 into number of term becomes 2. If I add 1 into 2, which is the number of term, becomes 3. If I add 1 into 3, which is number of term, it becomes 4. So if I add 1 into 4, it becomes 5. So I can say 6 is 1 plus 5. So an should be what? I just add 1 into n. So now look at the denominator. So it looks like 3 is if I add 2 into 1. If I add 2 into 2, it becomes 4. To get 5, I have to add 2 into 3. To get 6, I have to add 2 into what? 4. To get 7, I have to add 2 into 5. So to get this term, I have to do is add 2 into what? N plus 2. So this is my nth term. Hence, the nth term of the sequence is n plus 1 over n plus 2. Since the terms in the sequence, negative 2/3, 3/4, negative 4/5, 5/6, negative 6/7 have alternate signs. With those in odd position, like position 1, position 3, and position 5, they are negative. So the nth term of the given alternative sequence becomes this negative 1 to the power n times n plus 1 over n plus 2. So if n is 1, it should be negative. If n is 3, it will be negative. And if n is 2, it's positive. Okay, so here we're going to define factorial. If n is a positive integer, then n factorial defined as n exclamation sign. So this is the way we indicate n exclamation sign, but we did this n factorial. And this is the expansion. You start with the number n, and then you subtract 1, and then subtract 1 again, and keep subtracting until you get what? 1. Okay, so 0 factorial is 1. 1 factorial is 1. Now 2 factorial, so you start with 2 until you get 1. So 2 times 1 is 2. 3 factorial will be 3 times 2 times 1. So it'll be 6. 4 factorial, 4 times 3 times 2 times 1, that will be 24. So n factorial, you can write n, and you can stop anytime you want. So it'll be n and then minus 1 and put factorial. Similarly, you can start with n, you can keep going, and you can stop here if you want, and so on. Okay, so here is a nth term, 3 to the n over n factorial. This is example 11. So we substitute n equals to 1 to get the first term. So it becomes a1, 3 to the 1 over 1 factorial. Remember, 1 factorial is 1, so 3 over 1 is 3. Now to get the second term, you get n equals to 2 in the formula. It becomes a sub 2 equal to 3 to the 2 over 2 factorial. So you can 3 squared is 9, and 2 times 1 is 2, so 9 over 2. To get the third term, we put n equals 3. So it becomes a sub 3 is 3 to the third over 3 factorial. 3 to the third is 27. 3 factorial is 3 times 2 times 1, which is 6. So you have a 27 over 6. Make sure you reduce it. So we come 9 over 2. To get the fourth term, you put n equals to 4 in the formula. So it becomes a4 equals to 4 cube over 4 factorial. 4 cube is 64 and 4 factorial is 4 times 3 times 2 times 1, 24. Looks like you can divide by 8, it will be 8 thirds. To get the fifth term, you put n equal to 5. So it becomes a5, 5 to the third over 5 factorial. 5 to the third is 125. So 5 factorial is 5 times 4 times 3 times 2 times 1, 120. So 125 over 120, we can divide by 5, gives you 25 or 24. So the first 5 terms are 3, 9 half, 9 half, 8 thirds, 25 over 4. Simplify ratio of factorials. So you have a 3n plus 1 factorial over 3n factorial. So by definition, we can expand. 3n plus 1 is bigger than 3n, so we can start with this one. So 3n plus 1 is the first term, and then reduce, subtract 1 to be 3n, and I'll see same. So we stop here, put factorial. So now you can see we can cancel out, gives you 3n plus 1. So here's an example 12b, 2n minus 1 factorial over 2n plus 1 factorial. So we start with the bigger factorial. We expand this one. So we write 2n plus 1, and next is 2n, and then 2n minus, now we get the same. So we stop here. So now with these two cancel, the answer is 1 over 2n plus 1 times 2n. So example 12c, 15 factorial over 5 factorial, 10 factorial. 15 is bigger, so we're going to start with this, expand this one. 15 times 14 times 13 times 12 times 11, 10. Now we have a 10 factorial, so we stop here, 10 factorial. So with 10 factorial, we can cancel with 10 factorial. We're left with 15 times 14 times 13 times 12 times 11. What is 5 factorial? For 5 factorial is like a 5 times 4 times 3 times 2 times 1. So if you multiply all this, putting on the calculator, it gives you this big number. And 5 factorial becomes 120. We can divide, it gives you 3003. What is recursive sequence? Well, recursive sequence is a sequence in which the value of any term in the sequence can be determined by knowing the values of the previous terms. So here is examples of recursive sequence, Fibonacci sequence. 1, 1, 2, 3, 5, 8. So it looks like first term, two terms are the same, but the third term is the sum of the previous two terms. Like 3 is the sum of the previous two terms. 5 is the sum of the previous two terms. Here's another Lucas sequence, 2, 1, 3, 4, 7, and so on. There's another sequence called Collat's sequence, 3, 10, 5, 16, and so on. Okay, so example 13, so we are given a1 is 15 and a sub k plus 1 is a sub k minus 4. So we have to find the first 5 terms. So we start a1 is 15, so write the formula a sub k plus 1 equal to a sub k minus 4. So to find the second term, we substitute k equals to 1. So it becomes a sub 1 plus 1 and a sub 1 minus 4. And a sub 1 plus 1 is a sub 2 equal to a1 is now put 15. So 15 minus 4 is 11. So now the second term is 11. First term is 15. Now to get the third term, we're going to put k equal to 2 in this formula, recursive formula. So this becomes a sub 2 plus 1 equal to a sub 2 minus 4. Now we use a sub 2 is 11. So it becomes 11 minus 4 is 7. So we have to remember third term is 7. Okay, so to find the fourth term, we substitute k equal to 3 in the recursive formula, which is ak plus 1 equal to ak minus 4. So it becomes a sub 3 plus 1 equal to a sub 3 minus 4. When it becomes a sub 4, a sub 3 is 7, so 7 minus 4 is 3. Okay, so fourth term is 3. Now to get the fifth term, we substitute k equal to 4 in the given formula. So it becomes a sub 4 plus 1, a sub 4 minus 4. A sub 4 is 3. So a fifth is 3 minus 4, which is negative 1. So the first 5 terms are 15, 11, 7, 3, and negative 1.